Hello, and welcome to the AI Research Roundup. I am Alex. Today, May 8th, 2025, we are discussing Think on Your Feet, Adaptive Thinking via Reinforcement Learning for Social Agents, a paper from Hugging Face's trending list, published just a few days ago on May 4th. This research paper proposes making AI social agents more human-like by letting them adjust their thinking depth. It introduces adaptive mode learning, or AML, where agents pick thinking modes contextually. The core is Adaptive Mode Policy Optimization, or AMPO, an algorithm using reinforcement learning, that is, learning from rewards, for this. This improves efficiency, using fewer tokens or data units, and avoids rigid, long chain-of-thought reasoning, where the AI shows every step. So this figure really illustrates the core idea. It presents a camping scenario. Two agents, one blanket, and both are cold. Part A shows a typical agent, which responds quite bluntly, but in Part B, we see the proposed agent using what is called adaptive hybrid thinking. Agent 1 uses a deep thinking mode, mode M4, which involves several steps like considering history and strategy, to offer a nuanced suggestion. Then, Agent 2 adaptively switches to a simpler mode, M2, to propose a compromise. This really highlights their ability to adjust reasoning depth. Alright, so building on that adaptive thinking, this diagram really unpacks the adaptive mode policy optimization algorithm. We see a policy model, which is the agent's core decision maker, receiving input and choosing a thinking mode. Its output is then evaluated by a reward model. This feedback, along with a comparison to a reference model using a measure called Kullback-Leibler divergence, or KL, helps calculate an advantage, a signal indicating how much better an action was than expected. This advantage signal, considering both mode and sample levels, then refines the policy model, teaching it to switch modes smartly. Okay, and to see how well this adaptive mode policy optimization actually performs, these main results are quite telling. The researchers compared adaptive mode policy optimization against other models, including large language models and lightweight reinforcement learning models, or LRMs, which are smaller, efficient models, on benchmark environments SOTOPIA and SOTOPIA hard. Across both goal achievement and overall performance, adaptive mode policy optimization consistently achieves the highest scores, highlighted in bold. This shows adaptive mode policy optimization outperforms other methods, like the GRPO technique, particularly when using foundational models like Qwen and Llama. Now, to visualize this further, these plots compare adaptive mode policy optimization with GRPO across their training dynamics. We see two sets for different foundational large language models, Qwen and Llama. Adaptive mode policy optimization, the red line, consistently results in shorter mean response lengths. While mean rewards and goal scores are comparable, the crucial difference is in mode selection. The graphs showing the number of times each mode is used reveal that adaptive mode policy optimization dynamically switches modes, whereas GRPO tends to converge towards using the most complex thinking mode more heavily. So, as we have seen, this ability of adaptive mode policy optimization to dynamically switch modes is really key. The main takeaway from this research, then, is that enabling social agents to adapt their thinking depth, much like humans do, leads to significantly more effective and also more efficient interactions. This adaptive mode learning framework, powered by the adaptive mode policy optimization algorithm, not only boosts performance in social tasks, but also cleverly reduces computational load by using shorter, more appropriate reasoning. It really is a fascinating step towards more human-like AI. That is all for this AI Research Roundup. Thanks for joining me.